Hello, my name is Craig Lomon, and I will be teaching you homework one. This is my lecture. We're supposed to teach it like it's an entirely new concept or something like that. We're going how to use it, how to perform it, and how to interpret it. So, what will be covered? What is SPSS? How to use SPSS, t-test and what they are, how to perform t-test with SPSS, and how to analyze the results of t-test. Now, what is SPSS? SPSS. SPSS stands for Statistical Package for Social Science. Now, I can't define what package is because it does multiple things, but think of it as in, we're at least in this example, we're comparing a bunch of means. Now, this, gets a little bit more complex, but that's what t-tests are. We're doing a bunch of means and comparing that. Now, before we begin, I want to make sure that we have our SPSS software launched and ready to use with the data set. So we're going to launch the SPSS software. So we're going to click it. Nothing's been changed. This is an entirely new software. Ignore the little thing I had previously opened. It'll take a little while to load, but we're going to use the little data set we're also doing. So for this one, we're going to create a new data set. We're not going to use a little query. We're not going to use anything else. We're going to create an entirely new data set. We're going to open it, and notice how we have nothing on. Now that's fine. If you want, you can create your own little data set. You can go for type, number, stuff like that. We can create it. Now for now, we're not going to do that. We're not going to create a data set. We're not going to focus on the difference, numbers, all that jazz. We're not. We're just going to upload it. So to do that, we're going to go to File, Import Data. We're going to go to Excel. Now, no, this is not a CSV file. However, it should auto-convert. If it doesn't, you might have to try the other options. However, at least on my computer, it does auto-convert to a .sav, and it allows me to open it. So it's totally fine. It should, notice it says running get file. Bam. We got a data set. We got name, your type, got all this stuff. Now, we have our little data set open. We're going to leave it there. I'm going to close it out for now, just so that way I can start from the beginning when we get to that point. Now, before we begin on what t-tests are and stuff like that, we're going to have to talk about some important values and important steps before you perform your t-test. Before we perform a t-test, we got to talk about null hypothesis and alternative hypothesis. Now, our goal is to reject the null. So let's say we're examining a machine that puts sugar in Coke. Now, our goal is that there must be 20 grams of sugar inside that Coke. It must produce 20 grams of sugar, and that must be the average. But now we're attempting to prove that the machine is not producing 20 grams of Coke. So therefore, our alternative is that it does not produce 20 grams of Coke. And our null is saying, okay, it's producing 20 grams of Coke. So since we're trying to prove that it does not produce 20 grams of Coke, that is our null hypothesis. So H of 0 is equal to 20 grams, and H of 1 does not equal 20 grams. Now, we got to prove the null is, if the null is valid, if invalid, if we reject it, accept it, all that jazz. So we got to, now that we know our hypothesis is, we must ensure that our results are correct and the unexpected result is not. Now, our unexpected result proved true, then the null hypothesis this is not correct. Yes, our unexpected results prove true, and let's say in our little example where we say, okay, then it does produce 20 grams of coke each time, then the null hypothesis is correct and stays. We have to accept the result. You can use another data set, you can prove it another time, but at least in this case, we're saying that the null hypothesis is true. Now, how do we prove it to be true or rejected? We're going to look at the little p-values. Now, the p, notice how it says 0.05. Now, when we times by 100, that's 5%. We're trying to prove that there's less than a 5% chance of, error. Its significance and stuff like that. Now, if there's more than a 5% chance of error, then the null hypothesis, is true. Now, if there's a more than a 5% chance of error, so let's say, okay, it produces 20 grams of coke and it's 19.99999. That is probably going to be more than a 5% chance, because we're trying to prove that it does not produce 20 grams. That's roughly 20 grams. So that's most likely going to get, closer to not having the expected result. Well, let's say it's producing 19.75. That's less than a 5% chance of error, because we're proving that it's not producing 20 grams. That's why we can say the alternative is true. It has less than 5%. We're showing that yes, the test is significant. So 5% error, not a good sign. Less than 5% error means that, okay, there's showing that it's pretty accurate. Now, t-value. What is a t-value? Since we're talking about t-test, it's the square difference between the means. That's, what we're going to talk about. We're talking about t-test. T-values are going to come up. Now, what are t-tests? They are used to compare the averages of two groups and then determine the difference via t-score, which, fun fact, let's go back one slide. T-value. Give me one moment. Now, what are t-tests? Yep. Now, we're going to talk about types of t-tests. In the SPSS software, independent unpaired t-test and two-sample t-test are going to be a little bit similar. And in fact, they're going to use the little same functions. It's one of those things where the SPSS software, I used a bunch of my stuff from the slides off of these lecture slides. So that's why they're similar. A little bit different, but a little bit, at least in the software, SPSS software, it's going to be roughly the same. It's going to have some differences and some caveats, but independent unpaired t-test, two-sample t-test are going to be the same, at least in the SPSS software, but they are different, so I would like to talk about it at least. Screwed up my first presentation already. Independent unpaired t-test. I want you to pay attention. This test is used when you want to compare the two means of two independent groups. Now, let's say we're checking sugar in Coke, sugar in Pepsi. Two different groups. There's different amount of sugars. We're going to compare the averages of the two unpaired t-test. Now, let's say pair t-test. Let's go to money. Now, we're going to have money from birthdays and money from holidays. You're earning money from a special occasion. High chance those are related and the money you earn is going to be related. Of course, this might not be an excellent example of paired t-test. However, you know, you can also do stuff like uh, hours worked, money earned. That's going to be paired. They're going to be similar, at least in this case. Now, another thing is one sample t-test. A one sample t-test is used to determine whether the mean of the sample is significantly different from a known population or specified value. One sample t-test is used to compare the mean of one sample to a known standard. The little U sign, I forgot, I don't know how to actually pronounce it. But let's go back to our little sugar cans, okay? This is an example of a one sample t-test. We're checking to see, okay, does the soda cans produce 20 grams of sugar? We're comparing it. We know the expected result. We know the expected sample size, but we're checking, is there a significant difference? This is an example of a one sample t-test. I'm going to go back up here. Little thing, we're based off my lecture slides. I feel like this does not apply to SPSS software, but I like to include all little one sample stuff. Or a two sample t-test is used to determine the difference of two independent samples. Which, let's go back up real quick. We're comparing the means. We're comparing the means. In the SPSS software, it's going to perform roughly the same. I need to catch my breath real quick. Give me one moment. I did this for 20 minutes and I screwed up because I forgot one thing. Differences. Dependent two-sample t-test, also known as pair test, is used to determine if there's a significant difference between the means of two related pair samples. The samples must be related, meaning that each observation in one group has to direct to an observation in another group. Pre and post test and experiments where the same participants are measured before and after an intervention. That is the two-sample t-test, or paired, which is a paired t-test, which is this one right here. The one-sample t-test is used to determine whether the mean of a single sample is different from the known specified value. You need only one data set for this. It's like grams of sugar inside of a Coke. We're checking to see if it has that 20 grams. Give me one moment. Independent unpaired two-sample t-tests is used to determine the significant difference between means of two independent samples. The samples must be unrelated, meaning the observation of one group can have no correspondence to the observation of two groups. The test assumes the two samples are drawn from different populations, like sugar and Pepsi and sugar and Coke. They are different, they are unrelated, but we can examine the sugar content inside the Pepsi and Coke. I don't know the actual, they're probably related in industry, but at least in this example, it is not. Alrighty. Now that we know what t-tests are, and the values to look forward to, the hypothesis. We will now provide, perform the each t-test with the data set supplied in the presentation. So, if you haven't already, download this example and how to use the SPSS. It'll automatically download a little data set that we can use. So we're going to go here. Already. No. We're going to reset because I like resetting. I spent my voice, I spent 20 minutes doing this presentation already. My voice is kind of a little bit hurt because I forgot what DF stands for, which you guys won't, or the purpose of this presentation won't. All right. So if you haven't, go to File, Import Data. We're going to go to Excel. It should auto-convert in this case. It does not matter. We're going to go for 2.16.1. Alrighty. So we got our data set. Everything is loaded. There's no difference between that one and this one. I just wanted to click this one first. Alrighty. Now we go to analysis. This is how we're performing our data set. Now remember how t-tests are comparing the means? Guess where we have to go? 1, 2, 3, 4, 5, 6, 7. Now, first we're doing an independent sample t-test. Now, in my slides, before we do it, we start with our null hypothesis and alternative hypothesis. This is very important because before we do any t-test, we got to have a null and alternative hypothesis so we can return or reject the null. So, we're saying, okay, the GPA of the gender. Now, in this example, male is 1, 2 is female. Sometimes it may be you can change the number, stuff around, but we're checking for males and females. We're saying, okay, there is no effect on GPA with gender for a null hypothesis, and there's an effect on GPA with gender in our alternative hypothesis. So we have our variables. We could technically add these. This really won't make a difference, or it would, different senses, but we're at least checking these two for now. Bam. Now, what are we looking at? I'm going to tell you. So N stands for the number of fit males and females, at least in this data set. So we got 28 females in this data set, 10 males in this data set. The mean, the average is, for the GPA, that should not be right. No, that's not it. No, that's the average of males and females, at least in this mean. But standard deviation, this is the average deviate. But GPA. F, significant difference. So this is what we're checking for. Is this greater than 0.05? Yes. Absolutely. Now with our null hypothesis, there's no effect on GPA and gender. We got to accept the null. But ignoring that for now, we're going to go explain what the rest fit. So we accept the null. No effect on GPA or gender. However, let's keep on going. The t-value. This is the difference between the means. Bam, bam. Now, notice how these assume this equal variance. This assumes that, okay, if these two were equal in n, let's say it was both 28, 28, this would be this entire section right here. Don't get me wrong, there's significance right here. That's still going to be the same, but it assumes that, okay, there's the same number of data, data entries for female and male. But in this case, it's not. But this is the difference between the means, at least if it had the same number of males, same number of females. Significance one-sided, two-sided, mean difference. Yep. Standard deviation, error difference, and upper and lower. This assumes that it is a two-sided. Alrighty, we got this. Now we're going to go back. We're going to say, okay, we have our independent test. Let's go to our paired test. Oh, also, I forgot to mention degrees of freedom. That's this little section right here. Independent sample size. That's what this is. Each of the little tests, hedges, yeah. Now, let's say there's the same number of older and younger siblings. Now, there is a difference between the number of older and younger siblings. Now, we're going to perform that analysis for real on this. So we're going to go analyze, mean. We're going to go for paired sample test, pair 1, numbers, variable 2. Here's our little things, pair 1. So are these related? No, or, well, it's two-sided, so, but yeah, we got our mean, we got our number, correlation. No, these are not related. The average, amount of older siblings, amount of younger siblings, less than one, because these are paired, it's one side, two-sided, and this is significance on each side. That's the paired. Now we're going to perform the main one. We have our paired sample, we got degrees of freedom, all that jazz, just like I said last time, but now we have two sides, so one side, two side, standard deviation, the number, which is actually even in this case, so that is not a bad sign. So we have an equal number. Now let's go to one sample t-test. Okay, let's hypothesize that the GPA is 2.0. Average GPA is 2.0. High chance this is going to be rejected. The null hypothesis is going to be rejected. The alternative is that the GPA is not going to be 2.0. It's going to be entirely different. Can we test this? Yes. We already know it's going to be rejected? Absolutely. But we're going to do it anyways, at least in this example, to show you how to perform the analysis of this specific t-test. So here we go. We go back to means. We go back to one sample t-test. One moment, drink some water. Oh, excuse me. What was our thing? GPA. We're checking the GPA. Since we're only checking one value, we're checking, is it 2.0? This is what we're looking for. This is the value that we're expecting. This is everything that we need. So notice how we also have this a bunch of stuff saved. This is, each time we do the analysis. Don't get me wrong, they're entirely different. No correlation, but they are a t-test. These are, little arrow shows you the most recent one. So don't worry about that, at least in this case. Now we're going to slow down for a minute so I can catch my breath because I've talked for like an hour straight. My voice hurts. Ugh. Okay. So N. Oh my God. Sorry, my voice actually hurts now. N. GPA, number of GPA entries, 38. You already know this. So everything adds up to 38, at least in the test. Standard deviation error. I mean, Ooh. Here's our t-score. And this is our degrees of freedom. So we get 37 degrees of freedom, which that is actually the fun part because the degrees of freedom stand for, it's n minus 1 or n at least, not n minus 1, it's n minus the amount of groups. So since we have equal variance assumed, that's n minus 2 because male and female. We have n is 38 in the paired sample, and n is 36, sorry, not 36, n is 37. Since we're, at least in the paired sample, that's two groups in one, so therefore it's going to be, that should be 36, yeah, I misread the wrong part. But degrees of freedom. One sample t-test, this assumes that, less than one side, one right side. Now, standard deviation, this assumes that, okay, is it upper, lower, two-sided? But I want to point out that it's still going to have a source of error. Now, the average mean in GPA was 3.111, 3.1, which if we compare to our data entries, you can see a bunch of 3.0s, bunch of them, and things that are greater 2.9. So that's, it shows that, and then it shows, okay, even the lower end and the upper end, there's still going to be a bunch of differences between 2.0 and 3.1 to 1. So it shows that, yes, there is a significant difference, so our null hypothesis will be rejected. This is our, other ways, Hedges corrections, Cohen's D, yeah. This is sample standard deviation, stuff like that. So degrees of freedom, t-score, that's the mean difference. Significance, if it's less than 0.01. Upper, so
that means, what am I saying? At least in the significance, it says, okay, there's a difference between the two, at least in this case. So we have entirely different values. So therefore, our null hypothesis would be sustained. Alrighty, that was my presentation. And two-sample t-test, since that's the equivalent same answer as independent t-test, we can use the independent t-test example for the two-sample t-test. Alrighty, thank you. Have a wonderful day. That was my presentation.